So in this segment we're going to be using our base 10 blocks, and we're also going to be using in the array model, or making rectangle, or we can call it the area model. We're going to be touching on a lot of different terms today, so I'm just going to put them up here. We're going to be talking about multipliers, multiplicands, products, factors, prime numbers, composite numbers, and multiples. So lots of different terms, and they're all going to be showing using this array or the area model or the rectangle model. Now in a lot of books and in manuals and things that you see using this model, a lot of times they don't separate the sides, but my pet peeve is to separate the sides of the question from the answer part, just so that the students can understand what the pieces are, what the names are, what everything is applying to what. So in our first example, we're going to be talking about sets of 2. So there's our first set of 2. I can call that the multiplicand because that's the pieces that I'm talking about. The number up here could be called the multiplier, but just as easily, and the answer piece could be called the product. Now, some teachers talk about those terms, some teachers don't. Personally, I don't spend a lot of time on those terms because with the model, this is 2 times 1, or we could say it's 1 set of 2. So 2 sets of 1, 1 sets of 2, they move back and forth, so they're confusing to me. And in higher grades, we usually just call them factors anyway. So on this side, we would say that we have a factor that is 2. And on this side, we could say that we have a factor that is 1. So all these terms can be used interchangeably, but I just like to keep them a little simpler. So I'm just going to take these words out, and I talk about these are my factors, and the rectangle that I'm going to make is going to be called my product. And that's the terms that I'm going to be using throughout. So in this example, I have a product of 2, and I can say that it has factors of 2 and 1. Now some students say, well, what happens if I did this with my... What happens if I did this? Would it still be the same? Well, it would still be a product of 2, and now what we'd have to do is we just say our factors are still 2 and 1, and it wouldn't really matter which way we're doing it. That's called the commutative property of multiplication, and it's important that students know that 2 times 1 is the same thing as 1 times 2, and when they're learning their times tables, instead of having to know up to 12 times 12, let's say, instead of having to know 144 of them, we can cut that in half because they're exactly the same in one direction as they are in the other. So it's a quick visual of that. And it can be written either 1 times 2 or 2 times 1. So if I look at the number 2 here, and I want to find the multiples of 2, what multiples mean is I'm looking for how the products are changing if 2 is my factor. So if I'm looking for multiples of 2, what I need then is my next multiple would be another set of that product. And so my product is now 4, and 4 would be a multiple of 2. My next multiple of 2, I'd take another one of those, and so now my next multiple of 2 is a 6. My next multiple of 2 gives me a new product, which is 8. The next multiple of 2 gives me a new product, which is 10. And so this number here is going to change every time. So now that I have new multiples, I have new factors. But I'm just looking at multiples for now. I'm looking at multiples of 2. So if I start with a 2, multiples means changing this product shape over and over and over again. Those are my multiples. If I wanted to look at the multiples of 1, so instead of having a group of 2 here, I'm looking for groups of 1. When I do my next one, I could work down if I want to think of it that way. So working down of this set of factors that I was using before, there's my next one. So now I have a product of 2. 2 is a multiple of 1. I change my product again to whatever shape I'm doing over and over again. So now I have 3. So this number here would change to a 3. And so I could say my product is 3. It has the factors of 1 and 3. But I'm also looking at just multiples. So my next multiple of 1, just going down, if I'm talking about 1s, would be a 4, and then a 5, and then a 6. So when I'm looking at multiples, I'm looking at repeating my products. So on my first one, I looked at 2s, and so I was looking at my pattern was going sideways. And on this one, I'm looking at my factor of 1, so I'm looking, my pattern's going this way. And multiples are changing my products over and over and over again. So if multiples are repeated product shapes, what are factors? Students always get those two confused. So let's do something like this. Let's say I have, what are the different ways of making a rectangle or a product with 6 blocks? The student might first say, okay, well, I'm going to take a row of 6. And there's one way of making it. So what would my factors of this diagram be? Well, on this side, I have 1. And on this side, I have 1, 2, 3, 4, 5, 6. So 1 and 6 are factors of the rectangle 6. So I'm just going to take these and just move them over here for now. So that's one way of doing it. But that's not the only way that I can make a 6. A student might also show the following way. And they can put it this way. So I've got 6 again, so I'm still working with my product of 6, and I'm looking for its factors. Well, now I can make it a 2 by 3 array, and so 2 and 3 must also be factors of 6. And students playing around a little bit would figure out these two are the only ways that I can make a rectangle of 6. And so when we ask what are the factors of 6, what we could be also asking them is, what are the factors of the product of 6? And they would be 1 and 6, there's that pattern, and 2 and 3, there's that pattern. So factors are the sides of my rectangles. If you can't make a rectangle then with that side, then that's not one of the factors of that number. Factors are the sides, multiples are repeated products over and over and over again.